In this video, we will learn about the principles of calorimetry or the principles of method of mixtures. Okay, now what is a calorimetry? So, it is a branch of heat in which we deal with the measurement of heat and its allied terms like specific heat capacity and thermal heat capacity of different solids and liquids. Now, according to the principle of calorimetry, if a hot substance is mixed or kept in thermal contact with a colder substance, then the two substances do not chemically react, then the two substances exchange the heat energy. Suppose a box of T1 temperature and another box of T2 temperature are in thermal contact with each other. Then, if say the temperature of T1 is greater than T2, so the heat will get transferred from this box to that box. Okay. Now, in this process, the hotter body gives the heat and the colder one receives the heat. Now, this heat exchange continues till both the substances attain equilibrium. Now, the same boxes which were initially transferring the heat from one box to other box, after some time T1 will be equal to T2. At this particular point, thermal equilibrium will be achieved and they will stop exchanging the heat. Now, this exchange continues till both the substances attain the same equilibrium. Now this equilibrium temperature is less than the temperature of a hot body but more than that of cold body. Now during this process of mutual heat exchange, if there is no loss of or wastage of heat energy in the surrounding, then we can say that the amount of heat energy which was lost by one body would be equal to the amount of energy which is gained by the cooler or receiving body. Okay, as here we have two substances or bodies are mixed so as to exchange the heat. The principle of calorimetry is also known as the principle of method of mixtures. Now this principle is based on law of conservation of energy. Now mathematically we can say that, let's say we have a substance A of m1 mass of C1 specific heat capacity and initial temperature as T1. Now it is mixed with B substance M2 mass, specific heat capacity C2 and initial temperature T2. Now if T1 is greater than T2, then I can say that heat will transfer from A to B, or I can say A will give heat to B, or I can say the substance B will receive heat from A till both the temperature become equal. Okay. Now I can say that both will attain a T temperature. Okay. Now this T temperature will be less than T1 but will be greater than T2. Okay, it is logical. So I can say that for the fall in temperature of A, I can say delta T1 will be equal to T1 minus T. Okay. Now, the heat energy lost by substance A, that is Q1, would be equal to M1 C1 delta T1, or I can say M1 C1 T1 minus T. Now, again, the rise in temperature of substance B, that is delta T2, would be equal to T minus T2. So the energy or heat gained by the substance B, that is Q2, would be equal to M2C2 delta T2, that is equal to M2C2 T minus T2. Okay. Now if I assume that there is no wastage of heat to the surrounding, then the heat lost by the substance A would be equal to the heat gained by the substance B. So I can say M1 C1 delta T1 will be equal to M2 C2 delta T2. Or I can say for common temperature, T would be equal to M1 C1 T1 plus M2 C2 T2 divided by M1 C1 plus M2 C2. Okay. Now, what is a calorimeter? So, calorimeter is a cylindrical vessel, as you can see in this particular figure, which is made up of thin copper sheets, and it is used in calorimetry to contain a liquid or a solid in the form of fine particles. Okay. Now it is made up of copper, as you can see in this particular figure as well, because copper is a good conductor of heat and it has a small specific heat capacity. Therefore, it can acquire the temperature of the content very soon, right? Now it is made up of thin sheets so that the thermal, that is thermal heat capacity, is small and the amount of heat taken by it from the content so as to acquire the temperature of the content is negligible. Okay, so that it can easily at a faster rate can attain the temperature of the content. Now shown in the figure, the copper calorimeter, that is this part, is placed in a wooden vessel or a wooden box, and the space between the calorimeter and the wooden vessel is known as the wooden jacket. It is filled with wool or felt, etc., which is a thermal insulator. So this is, that is, the wool part is used for thermal insulation, and to avoid any heat loss by the calorimeter due to conduction, the calorimeter is covered with a wooden lid on the top to avoid heat loss by convection. Now the inner and the outer walls of the calorimeter are polished so that there is no heat loss by radiation. Now there are two holes in the lid, as you can see in this figure as well. One for a thermometer to measure the temperature of the content inside it, another a copper stirrer to steer the content inside the calorimeter so as to maintain a same temperature or constant temperature of the content throughout the calorimeter. Now, what is the mathematical statement of method of mixture when one of the substances is taken in the calorimeter? Now, if one of the two substances involved in the method of mixtures, let's say B substance is taken inside the calorimeter of mass M and specific heat capacity C, then the initial temperature of calorimeter, let's say T2, that is same as that of substance B. Now assume this is substance B having T2 temperature. Okay, so the calorimeter will attain the same temperature. Now on mixing A and B, the calorimeter also gain heat, that is Q3, that is mCT minus T2, where T is the final temperature of the mixture. Now, as per the principle of calorimetry, heat lost by the hotter body, that is A, would be equal to the heat gained by the colder body B plus the heat gained by the calorimetry in this case. Okay. Now, QB can also be written as Q2. Okay. Now, so I can say that Q1, which is M1 C1 T1 minus T, would be equal to M2 C2 T minus T2 plus MC T minus T2. Okay. This is the heat gained by substance B and this is the heat gained by calorimeter. Okay. Now on shuffling the values, we will get T to be M1 C1 T1 plus M2 C2 plus MC multiplied by T2 divided by M1 C1 plus M2 C2 plus MC. Okay. I hope this topic is clear to you. Thank you.